Good morning, everyone. So before I start explaining what we have to do for today, explaining today's part, I want to show you something. So now we're in week 4, the one I'm pressing on right here. If you go down, you will see something called Earth Day. This was posted by the Eco Club, not me. So I'm gonna press on Earth Day. Okay, this is some activities, videos, and that see, this is a to-do list. There's an audio here that explains what to do. There's a do-it-yourself project. This is not for science. It's mainly for Earth Day. It's extra, okay? And if you do it, you get extra marks. It's not something that you have to do, but it's there. You have the whole week until like next Sunday, okay? So go in, check it out, see the to-do-yourself or do-it-yourself project, see if you want to do something. It's pretty much fun and it's educational. You can learn about Earth Day and why it's called Earth Day. Okay, so week 4, we're going to go in. So you're in week 4, day 1, April 12. Okay, so this is a worksheet you have to do today. So these are the slides. Okay, today we're going to be learning about what heat is, basically. So we're still in the lesson temperature and heat. Okay, so basically heat is the energy that is transferred between two objects that have different temperatures. Okay, so the two objects need to have different temperatures so that heat can transfer between them. Okay, like for example, look at the stove. This is hot and this is cold. Okay, so the heat transfers from hot to cold, goes from here to there, and it has to, they have to have different temperatures for the transfer to happen. Okay, we have here object 1, high temperature, and object 2, low temperature. And we learned that temperature transfers from the high to the low. Okay, now if you notice, the thermal energy in the high, you see these arrows here, okay, they show you that the thermal energy is faster than these arrows here that show you that the thermal energy is slow. Okay, thermal energy, we mean by kinetic energy of the particles. Okay, so when thermal energy is transferred to an object as heat, the kinetic energy of the object will increase. So first they're moving slow in the low temperature, but then when the high temperature moves here, they start to move faster, the particles inside. Okay, that's because their kinetic energy, okay, that means the energy of movement of these particles increases. Okay, the temperature will increase, but so does the kinetic energy. So when the temperature increases, the kinetic energy increases as well. Okay, let's go and see an example over here. Okay, what happens is you have two objects. You have A, you have B. A is hot and B is cold. Okay, now I want you to see something. Now we put these two together and then the heat starts to transfer from the hot to the cold. Okay, and it keeps transferring because they have different temperatures. A and B, they have different temperatures. Okay, and the temperature starts to move from the hot to the cold until they keep moving. The temperature keeps moving until both of them have the same temperature. Okay, the two blocks are the same temperature as heat flow stops. Okay, the heat flow will only stop when the two blocks have the same temperature. It might take a few minutes, it might take a few hours, depending on whatever the size, the mass, and all that stuff. Okay, so in summary, okay, you got two objects of the different temperature. One is hot, one is cold. When they are joined together, okay, here the temperature flows between them until they become the same temperature, and then it stops. Okay, now look at this example over here. Okay, here they're going to show you in particles so you can see the kinetic energy. Now in the hot one, okay, where it has high kinetic energy, this has low kinetic energy. You see the particles here are moving slower, and the cold one, here they're moving faster and they're taking up more space. Okay, now we put these two together. Okay, the kinetic energy of this one starts to increase. The temperature moves from here to here. Okay, until they became the same temperature. We call this thermal equilibrium. Equilibrium comes from the word equal. That means same. Look at the thermometers here, down there. So you have two, warm object, cold object. You have two thermometers. One shows you the hot object, and then this one shows you the cold one. That it has lower temperature, and then the heat transfers happens here. Okay, when you put them together, the two objects. Okay, when you put them together here, you will notice that they become the same temperature. Same. And look at that. Same temperature. Okay, this is where the heat transfer stops, because they become the same temperature. And that's all you have to know for today. That heat moves from the hot to the cold. Okay, and it keeps moving until you get the same temperature in both objects. And the kinetic energy in the hot is more, in the cold it's less. Okay, and then when the heat moves from here to here, the kinetic energy here starts to become more. Okay, that's just in summary. That's all you have to know for today. Please finish the worksheet. It's pretty easy. Good luck. If you have any questions, please don't forget to ask.